We want to understand what is the size of the ions. So we said transition metals are going to lose their valence electrons. Of course, if you look at this transition metal, and if you write the configuration, do you see the outmost electron, valence electron, or fourth shell? Yes. N is equal to 4. Do you see, although 3D has more energy than 4s, however, it belongs to third shell. So when atoms are reacting, when they are making ions, they interact with the outmost shell. So do you see, if iron is going to make an ion, it's going to lose 4s2, not 3d6. Why? Because d6 belongs to third shell. It's the fourth shell, which is valence shell, which is the outmost shell. So what is the electron configuration of Fe plus 2? Well, Fe is going to lose these 2 electrons. It's going to lose these 2 electrons. So this is the electron configuration of Fe plus 2, which is argon and 3d with 6 electrons in it. Can you guess what would happen now if Fe plus 2 is going to lose 1 more electron? Which subshell is going to lose electron? Look at this, it's losing 1 electron from 3d, because 3d electrons have more energy than 3p. So this is the electron configuration of iron plus 3, which is argon, and 3d has got 5 electrons. Now, why is this preferred? Actually, iron plus 3 is more stable. Because if you have 5 electrons in D, you are going to have 1 electron. You are going to have 1 electron in each of the 5 orbitals of 3D shell. Do you remember we said there is extra stability if we have half-filled subshell? This one doesn't have half-filled subshell because 1, 2, 3, 4, 5. So it has got 4 of the orbitals. It has got 4 of the orbitals half filled, but there is 1 of the orbitals which are totally filled. By losing 1 electron, loss of 1 electron, is you are going to get higher stability of half-filled subshells. Okay. What is the structure of manganese plus 2? Well, let's look at the electron configuration of manganese. If you use the periodic table, the way we talked on previous chapter, you will end up with argon 4s2, 3d5. And if this is going to lose 2 electrons, is it going to lose from fourth shell or third shell? Obviously fourth shell, because that is the outmost layer. That is the valence shell. So this is going to be electron configuration of Mn plus 2. I hope this makes sense. If you don't remember how to come up with this, check previous chapter, chapter 5. You find the noble gas, which is closest by electron to manganese. You move from noble gas in order of increasing atomic number. You pass 2 cells in S block, and when you enter into D block, Manganese is the 5th element. Just go back to chapter 5, please, and make sure you understand these. All right. So when we make a cation from an atom of transition metal, they always remove electrons from NS orbital and not from N-1d. But if they lost the NS electrons and losing electron from d orbital, which is the outer shell electron now, is going to make the ion more stable, they will do that. That was the case with Fe+3 formation. So, guys, what do you expect to happen when an atom loses electron? Lithium is a metal. Metals lose electron. Do you see Li plus is much smaller than its metal Y? Well, obviously, loss of one electron, especially in case of lithium, is losing a whole shell. Lithium has got 3 electrons, right? Let's say 3 protons here, 2 electrons, and 1. 2 electrons and 1 electron. This is shell number 1 and shell number 2. So do you see, if 1 electron is gone, this whole shell, the second shell is gone. That means the 3 protons which were pulling 3 electrons, now they have to pull 2 electrons. These electrons are going to get closer to the nucleus. Atom is going to get smaller. So can I say when metal lose electron, their cation, which is formed, is smaller by size? And fluorine, if fluorine you obviously see is gaining electron, can I say addition of 1 electron is going to increase the repulsion between the electrons? See, this is fluorine. 9 protons, 2 electrons, and 7 electrons. And if this is gaining 1 electron, can I say number of protons are not changing and number of electrons are changing? So repulsion between electrons is going to make the atom larger. Also, attraction of 9 protons over 10 electrons is much weaker than attraction of 9 protons over 9 electrons. So anions are larger. Anions are larger than their atom. Cations are smaller than their atom. I hope this makes sense. So cation is always smaller than atom from which it is formed. And anion is always larger, see, larger than the atom from which it is formed. All right. And this is actual proof of what we just said. If you please look at periodic table in your book, in the cover of your book, the front cover of your book. As we move lithium, as we move from lithium to sodium to potassium to rubidium to cesium, we are going down the column of 1A. And we already said this. As you go down a column, atoms are getting larger. Now, look at the size of the lithium ion relative to lithium atom. Do you see lithium is much smaller? How much? Let's 53, maybe 53 picometer. and the atom is 150. The atom is reduced to 1/3 of its size when it becomes an ion. You see the same pattern. Every atom which made a cation, every metal which made a cation by losing electron, it became smaller. And the pattern remains the same. As you go down column 1A, the cations of the metal also are getting larger. Left to right is getting larger. In a column, top to bottom, the size of the atoms are getting larger. The size of the ions are getting larger. Okay, now let's look at another column. This is column 7A. This column that we were looking at was column 1A. Please look at periodic table in your book so you can understand this. Go to 7A. Start from the top, which is fluorine, and go down the column, which is iodine. Do you see the size of the atoms in periodic table are getting larger? This is the general pattern. As we go down the column. All right. What happens when fluorine is becoming fluoride? When fluorine is becoming negatively charged fluorine, you're adding electron. Repulsion between electrons are increased. Attraction by nucleus is decreased. So do you see? Fluorine is getting larger when it becomes fluoride, almost by a factor of 3, 50 something versus 150 or 140. And the same pattern is observed. Anions are always larger than their neutral atom because they gain electron. Also, as you go down the column, the anions are getting larger as well. Column 7A, the anions of these atoms in column 7A are getting larger as we go from fluorine on the top of the column to the bottom of column 7A. So in ionic bond formation, there is change of the size of the atoms after they lose and gain electrons.